Welcome to week 12 of our revision. This week we are looking at how data is transmitted over a WAN, such as the internet. And we're looking at what WANs are, packets, IP addresses, and packet switching. And this is paper 1, 1.3b. Okay, make sure you have revision sheet 12 given to you, ready with pen to complete. So, start off with just remind yourself, what is a WAN? A WAN, remember, is multiple LANs that are connected in different locations geographically, different places over a wide area. It could be around the country or it could be around the world. Remember, in a LAN, the company or the organization owns all the hardware, but in a WAN, some of the infrastructure like the telephone lines and things have to be hired because it would be unsuitable to put up yourself. So it is more expensive to run a WAN, and you have to have some other connections, and the biggest example of a WAN is the internet. So the one main thing to understand is that a WAN makes use of routers, and a router is a device that transmits data between different networks. For example, a LAN to a WAN, it connects them, and they are used to direct the data across a WAN. It reads the IP address of packets of data and sends it onwards, and each router has its own public IP address as well. So a LAN can be connected to the internet. So routers direct the data across a WAN. And there you can see an example of a WAN with lots of different LANs connected. Each has at least one router that connects it all together, and there are lots of routers that connect and transmit the data inside the WAN itself. Complete the section on your sheet, please, about WANs. Okay, PowerPoint pens that are ready, checking your answers. So WANs connect different LANs that are in different geographical locations, different locations around the country, around the world. And some of the infrastructure is hired in a WAN, such as communication lines. Purpose of routers: transmit data between two different networks, for example a LAN to a WAN, and it directs the packets of data across a WAN. We'll look at this more in a minute. Okay, let's move on. So we know what a WAN is. How is data sent across a WAN? Well, remember, a WAN has many different computers in it, okay? And there are different protocols that are used. So on a LAN, data is broken up into frames and we have MAC addresses. But how about on a WAN? While transmitting data on a WAN, data is broken up into little chunks called packets, equal-sized packets. All the packets are the same size. The packets are sent across a WAN using the TCP/IP protocol. Okay, so a different protocol for across a WAN. Every packet, every little chunk of data has information in the header such as the destination IP address of where the packet's going to, the source IP address of where it's come from, and a packet number. Each packet has a number so it knows the order. It also has the payload, the small chunk of data, and a checksum to make sure all the data has arrived intact. It hasn't been corrupted. So they're broken down into packets. The TCP/IP protocol is used to send each packet and direct it, and IP addresses are used to get it to its destination. Ping, 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 ping across the internet. And routers are used to direct the packets onwards, like we mentioned, across the WAN. And we'll look at what packet switch is in a bit. So fill in this section on your sheet about packets and the protocol that's used. Okay, time to check your answers, please. PowerPoint pens to add and correct. What are files broken down to on a WAN? They are broken down to equal-sized packets of data, and you've got a picture of a packet there. What's included in the packet and why? Well, you've got the source IP address, the destination IP address, and the packet number so that it can find its way across the internet. And the packet numbers are so that the data can be organized back into the correct order. You've also got the payload, the chunk of data, and the checksum to make sure that it hasn't been corrupted. And what protocol is used to direct the data on a WAN is the TCP/IP protocol. Once you've checked, let's move on. Okay, so we've mentioned here that on a WAN, it uses IP addresses. What was an IP address again? So remember, there are millions of different devices connected to the internet. PCs, computers, mobile phones, even things like fridges and TVs can connect now. So each device needs some way to be identified to connect to that network. And as a result, we have IP addresses. So every single device that's connected to a network has to have an IP address so that it can be found and connected and transmitted on a network. So an address given to a device so it can access the network and send and receive data over the WAN, over the internet. IP address. So there are different types of IP addresses we can look at, but every IP address, it's not linked to hardware like a MAC address, it is given to the device. They're either static or dynamic. Static means it's permanent and it will not change. Dynamic means the IP address can change every time you access the network. It's cheaper and can be reused. So there are two versions of IP addresses that you need to know about, and they have asked this in the exam recently. IP version 4, IPv4, is made up of 4 groups of denary numbers up to between 0 and 255, and they're separated by full stops. 1, 2, 3. 4 groups of denary numbers up to 255, between 0 and 255. Each denary number represents an 8-bit number in binary. And with that, you can have over 4.2 billion different IP addresses, which sounds a lot, but actually, we are getting to that amount of devices on the internet now. There is another version of IP address, IP version 6, IPv6, and this was first introduced in 1999. In IPv6, there are 16 pairs of hexadecimal numbers, pair along here. Each pair represents a 255-digit denary number. Main differences with IPv6, you can have over 340 trillion different IP addresses, which is way more than the IP version 4. Enough for all the devices in the world, basically. So, IPv4, 4 groups of denary numbers separated by full stops, up to between 0 and 255. IPv6, 16 pairs of hexadecimal numbers. Complete this section now. Purpose, IPv4, IPv6. Pause the video, then continue when you've finished. Okay, time to check your answers. IP address, the purpose, used by routers to direct the packets of data on the WAN or the internet, and they can be static or dynamic, static fixed or dynamic changeable. IP version 4, 4 groups of denary numbers between 0 and 255, and they are separated by full stops. And make sure you've got an example. Any example is suitable as long as it's between 0 and 255 and 4 groups of numbers. IPv6, 16 pairs of hex digits, enough for all the devices in the world, and again, give an example. Any example that has digits between 0 and 9 or A to F as the digits for hexadecimal. Last section, very last section on your sheet today. So we know about WAN, we know about IP addresses, we know about routers. What is packet switching? Well, packet switching, remember, data is split up into packets, they're given IP addresses, and they go across the internet. And routers are used to direct the process. This whole process is called packet switching. So remember, routers are used on the internet. Packet switching is used by routers to direct the data packets using their IP addresses, the destination IP address. Routers read the packets of data and then direct them onwards along the fastest route. Packets can take different routes across the network because a router might go offline or one might get busy, so the packets can go in different directions. As a result, the packets can arrive in a different order or the wrong order because they've taken different routes. Some might have got there quicker. So the packet numbers are used, they're very important to reassemble the data back into the correct order. Every packet is given a packet number and the packet numbers are used to reassemble it. If all the packets arrive intact, the destination computer will send a receipt to say, yep, got them all. If not, they are requested to resend them. This whole process is made possible by the TCP/IP protocol. Now actually, TCP/IP is actually two protocols that are working together. The TCP protocol splits the data up into equal sized packets. It does the splitting of the data into packets and it gives them a packet number. The IP protocol does the packet switching in the middle. It directs the packets from router to router to router along the fastest route. And then the TCP protocol checks all the packets have been received, it reassembles the packets back into the correct order, and it sends a receipt to confirm that they've arrived, or a message if a packet is missing or corrupt. So it does all the checking at the other end. So TCP are the rules for how the devices connect to the network, splits the data, reassembles and checks it, and the IP protocol is responsible for packet switching, directing the packets across the network using the routers. TCP, IP. On your sheet, very last section, how does packet switching work? Try to do it in the order. Think about how it starts, how it travels, and what happens at the other end. Purple pens at the ready to check your answers. So we have got TCP splits the data up into equal sized packets. Each packet has a number. IP protocol controls the packet switching as it travels, the packets travel across the network in the shortest route. Then at the other end, the TCP checks the packets have been received, reassembles the packets into the correct order using the packet numbers, and sends a receipt to confirm delivery of the packets. Purple pen, make sure you've got all that detail on this section. Final bit. Okay, final task for today then. Sheet should now be finished, all revision done. Go to LearnCompDean as always. You are doing a revision quiz 12. Revision quiz 12. So revision quiz 12 on LearnCompDean. As always, click check for each question. If you've got it right, great. If not, try another one. You are aiming for 100% by the end of the quiz. Revision quiz 12 on LearnCompDean. Do that now, please, and I will see you in lesson.